In this video, I'm going to talk about the maximum and the minimum rate of change in the directional derivatives. So before I get to the example, let me give you a simple hint. It might help you a lot. So if the question told you, for example, find the maximum or the minimum rate of change, so always the answer must be a scalar product here. So a scalar product means a number. So always the answer is going to be scalar product, so a number. Let's say, for example, another question came up and told you find the direction rate of change. So here you must know that the answer will be a vector, for example I, j, and k. Okay, so I'm going to give you one example to demonstrate this maximum and the minimum thing. So for example, let's say that a question came here and said find the maximum rate of change of f of x comma y and then comma z. Okay, and the question or the equation is x square root x square plus y square and then plus z square. Okay, and he gave you a point at p. A point is 3 comma 6 comma negative 2. Okay, and in which direction does it occurs, and also what is the minimum value of directional derivative. Okay, so to start, always if you want to start solution, you need to write the gradient vector. So to start with the answer, you write the triangle, it means the gradient, and then f gradient f is gonna be equal fxi, then plus fy, then j, then plus fz, then k. So here we have three variables for x, y, and z, and here x, y, and z, I, j, k. Okay, so from here we need to take the partial derivative for the original equation with respect to x and with respect to y and with respect to z. To shortcut the time, I'm going to write the answer, and you can find the partial derivative here really easy. Just convert the square root to a power, so it will be x squared plus y squared plus z squared to the power 1 over 2. And then if you use the power rule for the derivatives, after you move 1 over 2 to here, you write this the same, and then you will use the chain rule. So if you want to use the x, you take here the partial with respect to x. So you will take, for example, 2x, and all of these will be 0. For y is the same, is going to be 2y, and the others are 0. For the z is going to be 2z, and the others will be 0. For example, here y, and the third one is going to be 2z. Okay, so let's continue here. So the final answer here is going to be 2x over 2 to the square root x square plus y square plus z square. Then I write the I, then plus 2y over 2 times the square root x square plus y square plus this z square, and then j. Okay, then last partial is the z, so the answer is going to be 2z over 2 times the partial to the square root of x square plus y square and then plus z square. and then times k. Okay, so from here notice that I can cancel 2 with 2, and I can cancel 2y, or 2 with 2 also cancels, and the 2's here are also cancels. So then what I can do, that I need to I need to find the gradient vector with the point 3 comma 6 comma negative 2. So I'm going to fill every x with 3 and every y with 6 and every z with negative 2. Okay, so let me make some space here. So so uh, so from here, x here is going to be 3. So I'm going to write 3 over x square plus y square plus z square to the square root I, then plus y is going to be 6, then plus 6 over the square root x square plus y square, then plus z square. Okay, then I'm gonna write here j, then plus I'm gonna write negative 2 over the square root of x square plus y square, then plus z square, then times k, then times k. So what I can do here, okay, right now I need to find the maximum rate of change of f of x, y, and z. Let's let's say, for example, that I need to find the maximum and the minimum. If I find the minimum or the maximum, I can find the other one. So let me start to find the maximum rate of change. So we can write here that maximum rate of change, for example, ROC, maximum rate of change, okay? Then of f of x comma y comma z. So I need to find the maximum. As I said, you can use, or it's similar if you find the unit vector. So notice here that these fractions here are the same, right? So we can combine them together. Okay, so when we combine them together, we can get only one fraction, but at the top we need to find everyone's square root, and then we can combine them together. So let's find the square root, or the length of this square root. For example, here we have x comma y comma z. Okay, so here is going to be square root to 3 square plus the y is 6 square, 3 square plus, here's a 3, then plus 6 square, and then plus negative 2 square. Okay, so here in the denominator. But what about the top, denominator? I'm going to write also the same, 3 square plus 6 square, and then plus 2 square. It doesn't matter if I write the minus or not, because we have a square and the square will cancels the negative sign. So here I'm going to find 3 square is 9, and then plus 6 square is 36, and then plus the 2 square is going to be 4. And also here I'm going to write 9 plus 36 plus 4 to the square root. So here 36 plus 4 is 40, plus 9 is square root of 49, 49, and also here the square root of 49. So it's going to be 7 over 7. So the maximum rate of change is going to be 1. So this is the max. Okay. What about the minimum that I need to find? To find the minimum, you just multiply the final answer with -1, or you can multiply, for example, the negative sign with here. So the negative sign will not affect the solution with any way. So you can find the final answer to find the maximum, and after you find the maximum, just hit or multiply the solution with negative. So to find the minimum rate of change of f of x comma y and then comma z. So the final answer is going to be here. The minimum is gonna be -1. So this is the -1. Okay. Yeah, and this is it. Thanks for watching.